Good evening. How was your day? I was telling the fifth graders how much I miss you guys. I am really starting to get sad about all this. Because you two, especially, I can't have you next year. You're going to move on and become those teenagers that stink up our building. And that's going to make me very sad not to have you in my class anymore. But, yeah, I'm really going to miss you guys. If you could have your parents keep track of how long it's taking you to do your schoolwork, that would be helpful for me. I'm trying to gauge how much I've given you guys. I'm not thinking about giving more, but I want to make sure I'm not giving too much. And so if you could let me know that, that would be great. Do let the cat out. All right, so today we have to do some area on some figures that are more difficult than what you're used to. And at first it might look a little scary, but it's really not that bad. What I would like to do is start with B. Get my pen right here. Because B is probably the simplest one on here. So in B, if you were to see this shape, see the dotted line they put here? The reason they do that is because they want you to think of it as actually two shapes and not one shape. So what you're doing is you're making it into two rectangles, of which you know how to do the area. Remember, the area of a rectangle is the length times the width. All right. So the little trick would be is what is this length right here? Because they don't give you that length. Well, the thing to do is look at this length right here. That length they do give us. Okay. And they give us this part of the length right here. That's 5. So if we want to know this length, all we have to do is take the whole length, subtract it by this section right here, which we know is 5 meters. Take the 12 meters minus the 5 meters, which 12 minus 5 is 7. So that means this section right here is 7 meters. Okay, take a minute to just look at that. Make sure you get a grasp of what that's doing. Because they told us the whole length. Okay, and they told us this part right here, which is the same as up here. So if we subtract this part, then we'll know this part. Okay, let me erase a little bit. So while it looked pretty complicated, it's really not that complicated. I'll clean it up a little bit. All right. So for this rectangle right here, I'll do this one first. It's 9 meters this way. It's 5 meters this way, right? So length times width, 9 times 5. The first rectangle would be 45 square, what is this, inches. Are you with me? I didn't lose you? Okay, now this rectangle goes this way, okay? So the length we just determined is 7. The width over here is 4. So area is length times the width. So 7 times 4 would be 28 square inches. So the total area of this figure, add those two together, and you should get 73. Oh, why am I doing square inches? Are you guys all looking cross-eyed at me? Somehow I converted to square inches. Okay, meters squared. All right, that makes sense? Let's go down to our trapezoid, because that's probably the second easiest one. Okay? So once again, do you see this dotted line here? Oh, they may not always put this. As you get better at it, they're going to put that there. So you're just going to write it in yourself or mentally know it's there. So what we've done to this trapezoid is we've made it into number 1, a rectangle, and number 2, a right triangle. So we're just going to think of this as 2 shapes. All right. So area of a rectangle, length times the width. This is length of this one. The 16 down here includes all of this. Okay, so we don't want all of that. We only want to here. We do not want this part right here. So we'll do the rectangle first. 12 times 8. What is 12 times 8? 96 yards squared. Now, for the triangle part, for the triangle part, we're going to do like we did up here. So if they give us the whole thing as 16, and then this part, or this part, is 12, let's subtract the 12 out. 15 minus. So we know the base of our triangle is 4. The height of our triangle is the same as our rectangle. It's 8. All right. Formula for the area of a triangle. It's 1/2 times the base times the height. Remember, you're just taking the base times the height and halving it. A little trick, if one of them is even, we can half it. You could half this one, or you could half this one. You could half the 8 and make it 4, then times it by this one. 4 times 4 would be 16. What if we half the 4? Make it a 2 times the 8 would be 16. What if we just did the formula? What if we did base times height first and then halved it? 8 times 4 is 32. Half 32, and you get 16. Either way, you're going to get the same answer. And remember, that only works if halving one of the numbers only works if one of your numbers is even. If they're both odd, you're going to have to do base times height and then half it. We add them together, and I get 112 squared. Book, that is the correct answer. All right, hopefully that didn't confuse you. I'm going to get this out of the way, because now we have to do these circles. So you have this circle here, and they only want the area of the colored region. So the only thing that's colored are these little corners right here. This is all they want the area of. So how are we going to do that? Well, step number 1 is we're going to find the area of the whole thing. Okay? And it's a square. All they've given us is the radius of a circle. But if we turn that radius into diameter, then we'll have the distance all the way across, which would be the same as this and this. And because it's a square, same as this and this. So let's double 2.5 to get 5. So the diameter is 5. So our square is 5 feet all the way around. But once again, it's just length times width, or with square, the area of the square, they usually write it side squared. 5 squared, or 5 times 5, is 25 feet squared. So remember that, okay? Now, what we've done is we've found the area for all of it. All of this, okay? But we don't want all of this. We don't want that inside circle part, okay? So what we're going to do is we're going to find the area of that circle and then subtract it out of there. And that will leave us with just the green spots. All right, so remember the area of a circle? Area equals pi times radius squared. Okay, so the radius was 2.5. Let's square it. I'm going to do it right here, and I'll just erase it when I'm done. 2.5 times 2.5. I get 6.25. Did you? All right, now I got to take that 6.25 and times it by 3.14. And I'll do that with you. 4 times 5, 20, 7, 15, 8, 2, 6, and 24, 8. Isn't it great? I can just erase all this so easy. 10. If I did it right. Yep. Move the decimal over 4 places. It's 19.625. We're not going to write that 0 because we don't even need it. All right, I'm going to erase a little bit here so I have some room. How come I'm not working? There we go. I did that so I can erase that. All right. So we don't need that 0. So I'm left with 19.625. I don't think they round that up. Let me check my math book. No. Okay. So we have to subtract this guy out of this guy. So I'm going to start with 25 feet, and I'm going to put 19.625 under it. Remember, they got to line up those decimals. In 25, the decimal would be right here. All right, let's put some zeros up here to keep it interesting. And we're going to have to borrow. So what you got? How about that? How does that look? 5.375 feet squared is the area of the green parts. Wasn't that bad? Bunch of steps. But all stuff we knew how to do. And I understand when I was your age and was introduced to this stuff, it was just all Greek. But, all right. So if you missed some of that, you can always back up, pause, do whatever you got to do. All right, now, once again, this time we have a circle. And inside the circle, we have this triangular area that's not colored. So, sorry. Let's do what we did up here. We found the area of the square first. Let's find the area of the whole circle first. All right, so area equals pi times radius squared. This gives us the diameter. We don't want that. We want half of it. And half of 10 is 5. What happens if we square 5? We get 25. Do you agree with me? So I'm going to do 3.14, which is pi, times the 25. I know I go fast. If I'm going too fast for you, you can pause me. Isn't that wonderful? Don't you wish you had a pause button when we were at school. If I'm talking too much and I'm driving you crazy, you could just pause me. I added something wrong here. This doesn't look right. This should be an 8, shouldn't it? Yeah. Go over here and smart. Yeah. Okay. Put 2 decimal places over. So you don't need that 0. So we have the area of our circle is 78.5. Okay. I am going to get rid of this because we did the circle. Okay. Now we have this giant triangle. Okay. It says the circle with 2 inscribed congruent right isosceles triangles. Oh. Well, I am thinking that, let me just think for a second. I'm thinking we don't have to treat these as 2 triangles. We can treat it as 1. Because we can do the base here as a 10. And since this is the center point going out, okay, if half this way was 5, then this will be 5. You see what I'm saying? The radius. This is a radius right here. So this one is 5. So I have, oh, I see why they have to do that. Base times height, and then we're going to half it. All right, let's see if what I'm thinking works. All right, so let's do the area of a triangle. Because that triangle, we don't want that in the area. So let's figure out what the area of it is, and then we'll subtract it out of the triangle. All right, so area is 1/2 times the base times the height. And they do it a little bit differently than me, but I think I'll get the same answer. All right, so we could do 5 times 10 is 50 and half it and get 25. Or you could just half the 10, make that 5, and times it by 5. Either way. 5 squared. Okay, and that's what they got. They did it as 2 triangles. But I think there's no reason why I can't just do it as 1. Look at me, doodling like a crazy person. Doo-doo-doo. Here's your, whoops, sorry. Here's your base right here, which is 10. Your height is the radius of this circle, which is 5. Right? And what you're doing, if you do 10 times 5, you're figuring that. But we don't have any of this. So you're going to half it and get rid of that part. 1/2 times base times height, 25. All right. So our entire circle was 78.5. So let's take 78.5 and we're going to subtract 25. Right? Making sense? Clear as mud? Subtract. Voila. 53.5 feet squared, or square feet, however you want to write it. Are you thoroughly confused? Well, at least I did it with you. All right. Let me find page 2. Okay. Whoops. Not what I want to do. I can't ever get it to just flip right away. Let me try it again. Okay, let's try it again. There we go. I think this is it. Let me turn it. There we go. Okay. Let's look at this for a few minutes. And I'll let you go. All right. Using formulas and percents. A rectangle is 30 centimeters by 40 centimeters. Both dimensions are increased by 20%. What percent is the area increased. So they're going to increase both of these guys by 20%. Okay? So let's go through what they wrote here. What geometric formula and percent forms should I use? Well, first of all, what kind of shape is this? It is a rectangle, and so what geometric formula should you use? Probably the area. That's what I'm guessing. What steps do I use? Find the new dimension of your rectangle. That means increase your rectangle by 20% first. Find the area of the old rectangle and the area of the new rectangle. Find the percent of increase from the old to the new. So here they solve it. You are increasing it by 20%. And remember what I told you before? This was like with numbers. You could just times this by 20% and then add it to the 40, or you could save yourself a whole step by automatically multiplying it by 120%. And that will give you the old measurement plus the new measurement. I know it's a little confusing, but as you use it, it'll get easier and easier. So what they've done is they've done the length first, 40 centimeters times the 120% increase. And when they multiplied it, they get 48. So this was 40 centimeters, now it's 48 centimeters because it increased 20%. Then they do the same thing for the 30 centimeters. 120% times 30, and they get 36. So the new measurement is 36 centimeters. All right. So now they find the area of the old rectangle right here. Length times the width, 40 times 30 was 1,200 centimeters square. Then they did the length times the width for the new, bigger rectangle, 48 times 36, and they get 1,728 centimeters squared. Okay? Now what they do, remember percent of increase, percent of decrease. You always find the difference, and you divide it by the original number. So what they're doing is they're going to take the 1,728 right here of the area of the new rectangle, and they're going to subtract it by the area of the old rectangle. So 1,728 minus 1,200 is 528. Okay? Now you take the 528, divide it by the original number, which was 1,200, and 1,200. When you divide it, well, first they reduced it. 44 over 100 just means 44%. So it's a 44% increase. I remember teaching this years and years and years ago and thinking that there was kind of you could do this, you could definitely do this now, but I'm not going to take the time to walk through that. All right, extending the problem. Decrease the dimension by 20%. By what percent is this area decreased? All right, so we're going to do this together. I am going, let's see, I paid $8 for a pizza. $12 for 12. How many square inches did each get? Ooh, these are hard. These are really hard. How about I skip this? Because I've been on here long enough. I've been on here. And you're probably rolling your eyes thinking, okay, I've had enough. All right, let's just do this one. These are kind of important, but they're not easy. I'm going to erase all this just so when I write new stuff, you don't get confused. All right. So it says Zach paid $8 for a pizza with an 8-inch diameter. Okay, so we have an $8 pizza. I like to draw pictures. And it has a diameter of 8 inches. Okay? And Aiden paid $12 for a pizza with a diameter of 12 inches. Okay? How many square inches did each get? Find the percent of increase in price and the percent of increase in size, and which boy got a better deal. All right? So let's find the area of each circle. Area is pi times radius squared. All right, first circle right here, the 8 inches. All right. I'm going to do, where can I write? I'm going to write up top. Pi times, what's the radius of this 8-inch circle? Well, the radius is 4. What is 4 squared? 4 times 4 is 16. All right. So my little green box here, I'm going to do 3.14 times 16. Hope you're doing this with me. I know it's tedious, but we can get through it. $40.24. Does that look about right? I don't have anything here, so I'm guessing that that was 40.24. So, so I don't lose it, I'm going to do 40.24. All right, I'm not going to write the square inches or anything right now. All right, let me erase this because I don't have scrap paper on here. I'm going to erase that. Now let's do the 12-inch pizza. So if the diameter is 12 inch, the radius is 6 inches. 6 squared is 6 times 6. So that's 36. So now I have to do 3.14 times 36. And I'm going to go fast. You can see if you can beat me. 1, 2. All right, the area of the bigger pizza is 1,1,3,0,4. Quite a difference in the area, don't you think? From 40 to 13, it's amazing how that kind of stuff works. It doesn't seem like it's bigger, but it is quite a bit bigger. All right. So after we did that, it says how many square inches did each one get? Let me see if I got this right. They have 50 for this one. What did I do wrong on that one? I must have did some math wrong. Did you catch that for me? I did some math wrong. They have this as 50. I must have added something wrong. 50.24? I got the second one right. 113.04. Okay. So that's the answer to this one. So you should have that in square inches. Find the percent of increase in price and the percent of increase in size. Which one got the better deal? All right, so if I'm going to do let's do the percent of increase in size first. So let me erase this work up here because this is a good place to do work. So percent of increase, always find the difference first. So 113.04 minus 50.24. I wish I could hear you guys when I make a mistake. It would be very helpful, wouldn't it? Did I get that right? Okay. I'm just looking over my math. Okay. So now I'm going to take that 62.80. I'm going to get rid of this. 62.80 It's a lot of work. My gosh. Tons of work. 62.80 over the original, which was the first one, 50.24. They want you to divide that out. I'm sweating just thinking about all this. Oh, this is a lot of work. I don't know if I want you guys to do all this. This is so much work. It's 62 divided by 50.24. That just seems like an awful lot. I wonder if they want us to round this off. They don't show me that they're rounding or anything. Wow. I don't know. I think I'm going to quit with this. Is that terrible? Your parents think I'm terrible. But I'm going to quit with this because it's just getting too tedious. Especially since you don't have calculators. We did the area of the two pizzas. And we subtracted them. You can see the difference. I just don't want to do it anymore. I think we're going to quit here. I know you're not going to cry about it. So anyway, I think we're done for today. My guess is tomorrow, if I look at tomorrow's lesson, let me see. Oh, no, tomorrow's lesson gets easy again. We go back to doing some angles. And they don't have any of this on tomorrow's lesson. So I think we're going to quit with this because I don't have enough room on here to figure all this out. I feel a little bit guilty. I'm not going to be. All right, so let's be done for today. This was a long lesson, and this was a lot to learn, and adding this on the back probably just put you over the edge anyway. All right, so you guys have a good day. I'm going to move on now and get my language lessons done. Miss you guys and love you. See you later. Let me get out of here.